Wow. Okay, good morning. I realize, as she mentioned, I am the last person before you all have a break before lunch. So thank you for sticking around this morning. Marco, thank you for that amazing presentation. I think you're about to illustrate, or you have illustrated a number of the things that I'm going to talk about at a much higher level. So he showed you how it really is going to work. What I want to talk about today is really three things. Really, I'll talk a little bit about some of our servers and the infrastructure that we build, which you actually saw a little bit of an example of in the last video. I'll talk about Intel's role in creating open and trusted platforms. And then since I'm the solid-state storage guy, I will talk a little bit more about what we're doing with SSDs and how SSDs are actually helping drive some of the big data revolution. But first, I thought I'd start with a visual that a number of you may have seen kind of the virtuous cycle, the virtuous spiral before. The idea here is that, as Marco showed, there are millions going to billions of connected devices that are generating large and small amounts of data. That data is getting fed into data centers, and that allows for the creation of different services and capabilities. And from there, that leads to the creation of more devices, which leads to more data centers and more devices, and so on and so on. So we think we're at the beginning of a very large cycle of growth when you look at the Internet of Things, when you look at mobile phones, when you look at traditional computing, and to the problems that things like science is trying to solve. Big data has a huge opportunity, and we're just at the front of it. So we think that's obviously very interesting from an Intel perspective. So what's kind of driving all of this? Well, I talked about the huge growth in unstructured data, be it the car, be it the farmers in the field creating data, but that data has been available for years, or there wasn't a way to cost-effectively collect and analyze that data. And that's one of the things that's related to, we think, Moore's Law, in the sense that Moore's Law has really driven down the cost of computing. The ability of how much compute power you can put into a given area for a given price point in a data center has dropped by 40% in the last 10 years. That's been complemented by an even larger drop in the cost of storage, and that's both magnetic rotating media storage, a hard drive, and the innovations that they've had, but obviously we think a big part of that has been due to Moore's Law being applied to memory, non-volatile memory devices, and the building of SSDs. So by having low-cost compute and even lower-cost storage, that's made it cost-effective to collect huge amounts of data that you can go create services and other value-add applications on top of. And in fact, you're starting to see this as an industry estimate of how much is being invested in these new services, tools, and capabilities. So we'll talk a little bit more about that, but it's a huge potential, and people are really starting to invest. That's why we think we're only at the beginning of a very large growth cycle. From an Intel perspective, our view as to what role we can play in these industries really goes back quite a long way. Intel was one of the first and continues to be one of the largest providers of the Linux open source community, from a contribution standpoint to the distributions that we do to the number of platforms that we test the various Linux distributions on. And that's led to a huge growth of Linux across the industry and a number of different companies. The second big kind of strategic thing that we did was virtualization. In 2005, no one had a really big idea about virtual machines from a standpoint of building big data centers that would allow things like cloud-based services. But we believed in virtualization and the ability to put multiple workloads onto a single server. That endeavor about 10 years ago has really led to this huge growth of the internet data centers and some of the things that you've been hearing about today, and the ability to collect and analyze all of that data in an efficient way. The next thing that we've been investing in for the last handful of years is really the cloud infrastructure and hyperscale. And the idea here is that this is really going to happen, that not everybody has to own their compute infrastructure, and the ability to have it owned by somebody, a public cloud, and that you can just rent time on that in a very cost-effective manner through the use of virtualizations was something that we've seen for years and have been investing in, and again, we think will continue to grow over the horizon. The next big thing that we're talking about is what everyone is saying is big data. In the US, they've called it the next gold rush or the next oil boom. But we see it as a huge opportunity for new services, for new capabilities, and new experiences in solving problems that haven't been able to be solved before, things like the weather or genomic research. So again, a big investment area for Intel. So when we think about all of the value of this untapped data, right, let's just assume that the world takes advantage of low-cost networks and all these devices become connected and they're generating huge amounts of data. Today, things that aren't known or can't be predicted because we don't have a large enough pool of data can now be collected, analyzed, and acted upon. And this is really kind of the fundamental value proposition or concept around how big data works. The ability to go across, maybe not even just a farmer's field, but to correlate things across the country or across the globe, that if there's an industrial event happening in Japan, what is going to be the impact of air quality somewhere else on the planet, right? Big data allows us now to collect the amount of data needed to analyze it, predict it, and then actually gain new insight. One of the things I just read about that's happening in the US is that there's hospital chains that are now starting to use data that's been collected on cancer patients and cancer treatments as a way to standardize cancer treatments to actually lower the cost and actually make it available to more people. Up until now, a lot of the cancer treatments were very unique to a certain hospital or even specific doctors, and they would share that information, but they remained relatively cost prohibitive. The idea of collecting all that data and standardizing it is you can save more lives and make a better living experience for everybody on the planet. This is some of the things that big data is working on today and I think can really promise. At Intel, when we think about what we call the big data analytics platform or the framework, there's a number of building blocks. On the bottom, of course, you need to have a solid foundation, strong, high-performance networks, the ability to move that data around. Having servers and SSDs and storage systems that can actually manage and process that data is absolutely critical. Otherwise, you won't get the analysis in a time frame that's relevant, or you won't simply invest in it. Above that, you need to have some kind of a standardized big data platform. At Intel, we think Hadoop and our work with Cloudera and our own distribution are a critical thing to do that. We've just announced a big joint venture or investment with Cloudera to help standardize their platform across the compute industry. And once you have kind of standardized that Cloudera or that base Hadoop layer, then that allows people to go develop analytical tools and utilities on top of that, and then that's actually what helps us enable new usages and new experiences. Up until now, Hadoop distributions were somewhat limited to people that could actually afford to build their own data centers, do their own distribution, build their own tools and analytic capability, and then actually develop solutions on top of that. The idea here is that by working as an industry and as an ecosystem, we can standardize some of those capabilities, and that's actually what's going to help unleash or allow a lot of this growth to happen that we all kind of envision as an opportunity and solving a lot of the world's big problems. From an Intel perspective, as you might well imagine, we really have a few areas of focus. We think that by enabling a massive compute capability, building an open system, an open ecosystem, and then reducing the complexity of all those building blocks coming together is how we help accelerate the baseline. That's done through, of course, our Xeon processors and our other products focused at say, microservers based on Atom, but also our Ethernet adapters and building out 10 gig, 40 gig, or even higher speed frameworks of IP traffic that actually move that data in and out of the servers. And of course, having a Hadoop set of services and capabilities is a critical piece of that. And then the other part that I want to talk about is the role of the SSD and how we make big data happen and really driving all these capabilities. So for a very long time, actually almost as long as the compute industry has been around, there's been storage needed. You need to have a way to move that data in and out of a computer to make it worthwhile, to do something with it. And the hard drive, the rotating magnetic media hard drive, has been with us almost from the beginning. And it's done incredible things and allow us to build really large compute systems. But we think for a lot of instances, the time is changing where the mechanical capabilities can just not keep up with Moore's law and the electrical capabilities that you can get from non-volatile memory and solid-state storage. So I want to talk about how, again, that's really going to help us. When you look at what Intel does from a solid-state drive perspective, our fundamental belief is that, at least in the data center, what we're trying to do is move as much data towards the CPU as is physically possible. That actually gives you the ability to move data in and out very, very quickly and reduce the amount of time needed to do huge computes. But it also has other benefits. It also reduces the amount of power it takes, and it's also much more efficient, so you can actually do it with less servers. From a cloud computing perspective, Intel has been investing in years, and we have a number of key customers that are actually deploying our SSDs in big cloud. And in fact, Marco alluded to that they use a lot of SSD capabilities. In the HPC space, we've been doing a number of things. One of the examples is with the San Diego Computing Supercenter in San Diego, California. They actually have a large protein database that's used by medical companies to analyze proteins. And it helps speed the development of future drugs to cure diseases. And by deploying an array of Intel SSDs and replacing a bunch of their hard drives, they've actually been able to reduce the analysis time from 67 days down to 18 days for finding certain matches within their database to help solve problems. So now what was taking a much, much longer period of time allows you to potentially lock and find new drugs and solutions in a fraction of the time of what you could do before you replace it with SSDs. I have two more examples that I wanted to share with you of how Xeon processors, our Ethernet solutions, and our SSDs are being combined to create unique solutions. In Shanghai, the Healthcare Bureau has over 4,700 healthcare organizations that it has as a network. They are generating 160 million medical records every single day. This is a giant big data problem. What was happening was the records were getting entered. They didn't have a way to analyze them, so 80% of the time they didn't have the ability to detect and determine if someone had already had a treatment or had already had specific tests done. By using the solution that they put in place in this Hadoop infrastructure, they're actually able to reduce the number of retries from 80% to 30% of the time. So a huge cost and productivity savings, not just in that they could detect it and save time spent with patients, but it actually is a way to reduce healthcare costs because you didn't have people getting retested or reevaluated for something that they'd already been checked upon. So a huge boost in efficiency there. As another great trial that's just now actually happening around smart transportation, this is a great Internet of Things example. What they're doing here is putting telemetry data taking telemetry data from the 10 million trucks in this city and actually then feeding it into a central database and comparing it against traffic density and actually rerouting the trucks to make them more efficient, use less fuel, and actually create less accidents because it's a huge driver of accidents. And so, again, by using a concept of IoT and big data analysis, they're actually able to reduce the amount of traffic and speed up the flow of traffic in the city. So, as I mentioned, Intel sees big data as a huge future potential opportunity. And this is something we're investing in for the long term. Everything from investing in machine learning algorithms to enable things like machine-to-machine communications where it's even more efficient than actually having to have a person involved, to building analytical applications. Intel is working with a broad ecosystem from universities up through specific companies to work that we're actually funding inside of Intel. So again, we see this as a huge opportunity for us to work as a company, but then also on a global basis and build a very large ecosystem around this big data opportunity. So, in summary, we think that the work that we're doing in the data center is the best way to do processing for big data. We think Intel is uniquely capable of providing open, scalable, and trusted platforms. And then the way to most efficiently process and take care of those big data analytical problems that you have is actually combining SSDs with all those big giant data sets you're building. Thank you.
So thank you very much, Mr. Leslie.